This is a continuation of the very last video. In the very last video, we found the area between e to the x and the parabola x squared minus 1 from negative 1 to 1, excuse me. And when we did that, we came up with some very interesting things. Now, we did it all by hand, and we came up with the numbers. I'll do that in a second. But now what I want to do is revisit this, and we're going to use Simpson's method with 6 non-overlapping equal width subintervals. So the width of each subinterval will be the right endpoint minus the left endpoint over the number of equal width non-overlapping subintervals. 2 over 6 is 1/3. So we're going to start at negative 1. We add a third to that. That's negative 2/3. We add a third to that. Negative a third. We add a third to that. 0. Add a third to that. Add a third to that. And these are our sample points. So remember, Simpson's method says it's the change in x over 3. And now we calculate the heights. So I'm going to do the multipliers in a second. So f of negative 1 plus, leave this blank, f of negative 2/3 plus, leave that blank, f of negative 1/3. And when I was doing this, I forgot to copy one of the points down. Plus, okay, I was at negative a third, add a third to that, I'm at 0, plus f of a third plus f of 2/3, and finally f of 1. Now look, the first and the last point are only going to be in one parabola. But then, remember, all these other heights alternate. 4, 2, 4, 2, 4, 2. 4, 2, 4. Okay, so now we're just going to go ahead and we're going to put this on our computer. So let me get this out. Okay, look, I still have everything here. Now I believe I called it h of x, so we're going to use h of x. So h of 1 plus, and then I'm just going to go right through it. I have 4h of negative 2/3 plus, oops, get out of the parentheses, unlike Mr. Isaac, unlike Steve, plus 2 times, oops, h of negative a third. Now we're at negative a third. We're moving our way through it. Oops, not a half, a third. Okay. Now we alternate, plus 4 times the function's value at 0, plus 2 times the function's value at a third. Then don't forget 4 times the function, oops, not f, get out of that, the function's value at 2/3. And then finally, hold on, I forgot to put a 4 in front of that. That would have been a big whoopsie. Okay, come on. 4. And then finally, plus the function's value at 1. Okay, and wait 1 second. What? Hold on, let me go double check. Yeah, we did do this, so hold on, we must be missing something here. Oh. Okay. Let's do this. Okay, come on. Come on. Okay, hold on. Okay, I guess we're retyping this in. H of negative 1. And that happens. You make mistakes when you're typing and you have to redo it. H of negative 2/3. Okay. Now let's get out of that. Oops, and not capital H, small h. So I think this, oh, come on, don't. Plus 2 times the function at negative a third. Now get out of this. Plus 4 times the function at 0. Plus, now we're back to 2 times, oops, not 3, 2 times the function's height value we're at a third now. Now we're going to add 4 times the function's value at 2/3. And then finally, 1 times the function's value at 1. Okay? And we get 33 and some change, so I'm going to write that down. Now remember, our delta x is a third divided by a third. So, we're going to do some arithmetic. A third of a third is a ninth. So I'm going to go, okay. I wonder if let's see what happens if sometimes, let's see. Let's do, I don't know why it keeps saying P of X equals. Okay, P of X equals P of X, and we're going to divide that by 9. And, come on, tell me what that is. Oh, I can't believe it didn't give me that value. Huh. Okay, I'll just type it out then. 33.15505.338. That'll be enough precision. Divided by 9. Okay. And we get 3.68388942. And then, folks, that is using GeoGebra to calculate Simpson's method. And notice I have it right here. Now, it's set up, and this is what you would do. So, I will do another example. This next one will be solids of revolution with numerical techniques.